Hi friends, very good morning. Welcome to Anu Academy. So, very good morning friends. Let us start today's class. Today I am here in front of you with some solved problems related to simple stresses and strains which may expect in our exam, that is AE Assistant Engineering exam conducted by EPPSC. So let us see how we can get a problem related to simple stresses and strains, and how we can solve these problems, right? And how much time it takes to solve these problems. Because dear friends, we are writing engineering exam means definitely they will test all our skills, engineering skills, our aptitude skills, our reasoning skills, our logical skills, all types of skills. They will conduct a test for us. So definitely, as we are attending engineering paper, especially mechanical engineering, means we can expect many problems in our paper. Okay, so the related to the topic wise, related to the syllabus point of view, how we can attend these questions and how we can get good marks, we will discuss in today's class. Okay, if so, please subscribe our channel, please like and share our channel, please discuss with your friends regarding the class work going on in our channel. Okay friends, now we will start today's topic. As I told you, here in front of you with some solved problems of this simple stresses and strains. So now let me read this problem. An elastic rod 25 mm in diameter, 200 mm long, extends by 0.25 mm under a tensile load of 40 kilonewtons. Find the intensity of stress, the strain, and the elastic modulus for the material of the rod. So here what data is given in this problem is an elastic rod 25 mm in diameter and 200 mm long extends by 0.25 mm under a tensile load of 40 kilonewtons. So tensile load is 40 kilonewtons, diameter is 25 mm, and 200 mm is the length of the rod, but it is extended. How much it is extended? 0.25 mm it is extended under a tensile load. So for the given data, what we have to find here is intensity of stress. Okay, remember, intensity of the stress, strain, and elastic modulus for the material of the rod. Now we will see the solution. As usual, we will write whatever the thing is given: diameter of the rod, length of the rod, tension. Okay, now we will see area of the section. So each and every problem, as we are dealing with simple stresses and strains, definitely we have to find out the area of the particular section, respective section. So area of the section A is pi by 4 d square. So this is the area of the section. Intensity of the stress is P by A. Okay, force by area. So this is the force. Okay, by this is the area which we have calculated, and this is the value, it is in Newton per mm square. And strain, okay, this is the strain, delta by L. Okay, so once we are finding the strain, this is the strain which we have calculated. Okay, and here it is the elastic modulus. So what is elastic modulus? See, elastic modulus is intensity of the stress by strain. Okay, now elastic modulus is intensity of the stress by strain. So this we got in Newton per mm square. Okay, so the thing is, we have to read the question carefully, and we have to understand what exactly the examiner is asking from us. Like that, we have to understand the question. If we don't understand the question, we cannot go for the solution. So it's experts always recommend us in our examination, read the question once, twice, thrice, such that we can understand it and we can give a correct solution for that problem. Okay, now we'll move to the second one. Next problem. Here in this problem, cast in this problem a cast iron, I'll read it first. A cast iron column has an external diameter of 300 mm and 20 mm thick. Find the safe compressive load on the column with a factor of safety of 5 if the crushing strength of the material is 550 Newton per mm square. So here what he is asking, a cast iron column has an external diameter of 300 mm and 20 mm thickness, right? So diameter he gave and thickness he gave of a cast iron column. Next, find the safe compressive load. We have to find safe compressive load. Previous case, what we have calculated, previous problem we have calculated intensity of stress, strain and elastic modulus. Now here in this problem we are calculating safe compressive load on the column with a factor of safety of 5 if the crushing strength of the material is 550 Newton per mm square. Now we see the solution. See, first area of the column section. So once we put the values in here in the, we'll get the area. This is the area and safe stress in compression. So this is the safe stress in compression. So what he gave, 550 Newton per mm square. No, so 550 divided by factor of safety. So we got 110 Newton per mm square. Now we are going to calculate safe compressive load. Safe compressive load is what we have got in safe stress in compression, safe stress in compression into area. Okay, now safe compressive load, how we are calculating here, safe stress in compression into area. So we got safe compressive load, that is in kilonewtons. Okay, I think all of you are understanding this problem. See, these type of problems definitely we get in our exam, AE exam. If you see the previous year's question papers also, most of the questions are theoretical questions. Just they'll give one statement, they'll ask the formulas. Okay, but some cases we can find problems are given for 2 marks or 3 marks like that, and we can solve. So if we solve these type of problems, we can get good marks within less type of time. Okay, next problem. A 30 mm diameter steel rod, when subjected to an axial tensile force, was subjected to a strain of 0.60 into 10 to the power minus 3. Find the tensile force that caused the above strain. Take Young's modulus is 200 kN per mm square. Okay, so here what he is asking, a 30 mm diameter steel rod when subjected to an axial tensile force. So here which type of force it is subjected? An axial tensile force was subjected. A strain, what is the strain here? 0.60 into 10 to the power minus 3. Find the tensile force that caused the above strain. So here what we have to calculate, we are going to calculate the tensile force that caused the above strain. So Young's modulus, we have to take it as 200 kN per mm square. So stress is equal to strain into Young's modulus. We know that stress is equal to strain into Young's modulus. So what is the strain given in this problem? 0.60 into 10 to the power minus 3 into Young's modulus. So this is the stress. So we have calculated the stress. Next, what we have to calculate? Tensile force. Okay, tensile force is equal to stress into area of the rod. Okay, now tensile force is equal to stress into area of the rod. So stress, this is the stress we have calculated, and this is the area of the rod. So we got 84.82 kilonewtons. Okay, so options you will get to 4 values. So from that 4 values, after calculating, you have to select the correct option. Okay, now right, I think all of you are understanding. If you are having any doubts, please post in the comments box. I will give you a reply. Next problem. The above given figure shows a pressurized cylinder of 250 mm internal diameter provided with a sealing cover plate fastened with 12 mm diameter steel bolts. The pressure inside the cylinder is 2 Newton per mm square. If the allowable tensile stress in the bolts is 75 Newton per mm square, find the number of bolts required to fasten the cover plate. So first we will see the diagram. Okay, see friends, whatever the problem we are getting in the examination, as I told you starting of the class, first and forward we have to understand the question. So once we are getting some problems regarding these pictures, regarding the diagrams, regarding the figures, we have to understand the figure. So whatever the data is given in the figure, from the figure itself we can we can identify ourselves how to start the solution. Okay, so seeing this figure, so this is the figure given. So what he is saying in this figure, seeing the figure, a figure shows it is a pressurized cylinder. Author is saying, the examiner is saying, this is the pressurized cylinder of 200 mm internal diameter. So this is the internal diameter of 250 mm internal diameter, provided with a sealing cover plate fastened with 12 mm diameter steel bolts. Okay, these are the steel bolts. Okay, 12 mm diameter steel bolts. The pressure inside the cylinder is, the pressure inside, this is the pressure inside the cylinder is 2 Newton per mm square. Okay, understand the problem. Pressure inside the cylinder is 2 Newton per mm square. If the allowable tensile stress in the bolts is 75 Newton per mm square. So if the allowable tensile stress in these bolts is 75 Newton per mm square, so what we have to find the number of bolts required to fasten the cover plate. So we have to find how many bolts are required to fasten this cover plate. So I think all of you understood this diagram. This is the internal diameter, this is the internal pressure, these are the bolts, this is the cylinder. Okay, this is the cover plate. Now we will see how many bolts are required for this problem. So total upward force on the cover plate is P is equal to, so this is the formula for this cover plate. So once we substitute all these values, we are getting cover plate total upward force on the cover plate, that is the 31,250 pi n. Okay, we are taking pi as it is. Now safe tension per bolt is equal to, safe tension of the bolt is pi d square by 4. So once we put all these values, we are getting 2700 pi n. We are taking pi as it is. Okay, now number of bolts required is, how we are calculating the number of bolts here. See, previous step, total upward force on the cover plate, this divided by safe tension per bolt, we are getting 11.6. So it will be almost 12 bolts are required. Okay, understood? Okay, right. Now next we'll move to the next problem. Find the maximum and minimum stresses produced in the stepped bar shown in figure to an axially applied compressive load of 12 kilonewtons. Okay, this is the, so again we will see the stepped bar here. This is the stepped bar. Okay, I think it is clear for you. You can understand this diagram. So this is the stepped bar. Two steps are there in the stepped bar. The bottom one is 25 mm. The diameter is 25 mm. Top one is 12 mm. And what is the type of load acting on this stepped bar? The type of load, see, you can see the type of load. It is axially compressive load, that is 12 kilonewtons. Understood this diagram? So it's always we have to make a habit of understanding the diagram, reading the question, then only we can solve the solution within fraction of time. Okay, now we'll see the solution. Area of the upper part. Okay, area of the upper part. So A1 equal to, area of the upper part is A1. Area of the upper part is A1 is equal to, this is the area we are going to, we got this one, and area of the lower part is A2, same, we got this value. Now maximum stress. Okay, maximum stress, that's what he is asking. We have to find maximum and minimum stress. So maximum stress is max is equal to, this is the value, right? So once we put these values in this one, so we will get the maximum stress. Next, to minimum stress. So after calculating the maximum, this is the minimum stress. So we got the values and the units is Newton per mm square. Okay, I think these problems are, it will be very helpful for you. So this problem is under simple stresses and strains. This that's all friends for today's class. I think today's class will be very helpful for you. If you are having any doubts, you please post in the comments box. I will give you reply. Okay, so please subscribe our channel. Please like and share our channel. Definitely AE exam conducted by APPSC and TS Telangana State Public Service Commission. Definitely we are going to get problems. So if we have the habit of solving these type of problems, definitely we can score good marks in our examination. Thank you for watching.